Hi class, permutations versus combinations. Which technique should you use? Well, it all depends on how you approach the problem. For example, let's look at the case where we have 4 red marbles and 2 whites. We'll put them in a row in random order, and I'd like you to find the following 3 things. First, the probability that the 2 end marbles are both white, and then the opposite of that, the probability that the 2 end marbles aren't both white. And finally, the probability that the 2 white marbles are side by side. B is pretty easy if you can get A. Method 1 uses permutations. So for this method, let's define the sample space S to be every random ordering of the 6 marbles. Obviously, there are 6 factorial of those. Event A is defined as the 2 end marbles are white. So you have the situation white, red, 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 white. The cardinality of A is simply the number of ways to permute the 2 whites in the end slots times the number of ways to permute the 4 reds in the middle slots. And that, pretty obviously, is 2 factorial times 4 factorial, which is 48. So this immediately implies that the probability of the event A is the cardinality of A over the cardinality of the sample space S, and that's 48 over 6 factorial equals 1/15. And then just as easily, the complementary event, probability of A bar, is 1 minus P of A equals 14 over 15. Okay, great. Now let's look at the last problem I wanted you to do, the probability that the 2 white marbles are side by side. Now this can happen in 5 ways. If you have WW, RRRR, I sound like a pirate, RWW, RRR, or dot, 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 RRRR, WW. Sounds kind of funny. So the reason I know that there's 5 ways to do this is because the initial W can start out in one of the first 5 positions. So there's 5 ways to do that. So the cardinality of B is the number of ways to select the pair of slots for the 2 W's times the number of ways to insert the W's into that pair of slots times the number of ways to insert the 4 R's into those remaining slots. And that's equal to 5 times 2 factorial times 4 factorial, and that equals 240. And so therefore, the probability of B, the probability that the 2 white marbles are side by side, is 240 over 720 equals 1/3. Fantastic. So the issue, though, is that I'm really lazy, and this method took way too much time. So here's an easier way. Method 2, using combinations. So here, when I do the problem, I'm going to think about which 2 positions do the whites occupy. So now I'm going to redefine the sample space to be the possible pairs of slots that the W's occupy. So these are pairs of slots out of 6 potential slots. And so clearly, the size of the sample space is 6 choose 2. How many ways can I pick a pair of slots out of 6? 6 choose 2 equals 15. So A, here we're interested in the probability that the 2 W's, the 2 whites, occupy the end slots. So there's only one way to have a pair consisting of just the end slots, and there's 15 pairs. So the cardinality of A is 1, and that immediately implies that the probability of A is 1 over 15. Similarly, I won't go into this because it's obvious, probability of A bar equals 14 over 15. And in C, part C, we saw that the event in which we had 2 whites side by side, there were 5 pairs for which that could happen. So the probability of B equals 5 over 15 equals 1/3. That was way nicer. So we see that sometimes it's easier to play around with combinations. Sometimes it's going to turn out to be easier to play with permutations. But either way, it's an interesting comparison. Okay, great. In the next lesson, we'll have another cool application of counting techniques. So see you then.